Hello, everybody. Welcome back to Module 2 of the CHEG654 crash course. This video will cover the innate versus adaptive immune system, as well as some of the key players part of the immune response. Innate versus adaptive immunity. Your innate immune response is present from birth, and this provides a nonspecific rapid response as the first line of defense against pathogens that enter your body. This will oftentimes trigger an inflammatory response as a general reaction to these pathogens, and this includes neutrophils and dendritic cells. On the other hand, your adaptive immune response is built up over time. This provides a highly specific and slow response to specific pathogens, and your adaptive immune response develops memory for a specific response to re-exposure of a pathogen. So upon re-exposure of a pathogen, you will have a faster response and more targeted response to the pathogen. This includes T cells, B cells, and dendritic cells. So as I said before, a neutrophil is part of your innate immune response, and a neutrophil is known as a granulocyte, as it contains granules with enzymes and antimicrobial substances that allow it to perform phagocytosis. So in phagocytosis, the neutrophil essentially engulfs a microorganism as a way of fighting the pathogen and removing it from your body. And neutrophils will travel through your bloodstream to sites of infection. Dendritic cells are known as a gateway between the innate and adaptive immune response. So they're technically part of both responses. Dendritic cell is a monocyte, and it is also an antigen presenting cell. So this means that it will capture the antigen, and then with the antigen attached to it, it will migrate to secondary lymphoid organs where it presents antigens to T cells via MHC complexes. And this initiates your adaptive immune response. Moving on, T cells, again, are a part of your adaptive immune response and can be split up into two different classes. There are cytotoxic T cells, also known as killer T cells, and these interact with MHC class 1 molecules. Now, killer T cells will directly attack infected cells, and they kill them through the induction of apoptosis. And they do this with cytotoxic, or the release of cytotoxic proteins to these infected cells. On the other hand, helper T cells interact with the MHC class 2 molecules. Helper T cells help to stimulate B cells to make antibodies and also aid the development of cytotoxic T cells. Finally, B cells activated B cells undergo clonal expansion, and then after this clonal expansion, they will split up. They will differentiate into different types of cells. Now, effector B cells allow for a rapid production of IgM antibodies, but it's very unspecific. Then there are IgG expressing B cells, in which they undergo class switching to have a more targeted response, producing a better antibody class to fight the pathogen. And then finally, there are high affinity Ig expressing B cells. So some will undergo affinity maturation that enhances the binding of the B cell receptor, whereas memory B cells are by far the most effective at choosing the correct antibody.